Okay, so these variables, I have them listed back here. Exercise, temperature, drugs / meds, illness, somebody might be sick or not, like have a cold or flu, stress, smoking or a non-smoker. Do you have asthma? Some people have some breathing conditions like asthma, fight or flight. Okay, so are you scared? Where you have to stand and like defend yourself, or you're scared. Like imagine all the haunted houses going on right now, and how that affects your heart rate when you're going through that, or you're watching a scary movie. Okay, so these are the factors, possible variables that could affect the heart rate. And so we want to look at, well, why? Okay, so why might these affect our heart rate? Okay, so think about that as you're going through some experiments today. And we have some supplies around the room so that you can do some general experiments. And things that we have a water bath with warm water. We've got some ice water. And we also have some paper bags. And does anybody have like a Red Bull on them or like an energy drink, okay, that you haven't opened yet, but you are thinking about drinking it? So that could be, that's caffeine, and caffeine is supposed to be a stimulant, and so that could also be a test. But what we'd like you to do is we would like you to go ahead and test a few of these. So for example, let's say we take exercise, okay? So if our hypothesis is that if exercise affects heart rate, okay, so you're going to do an experiment. And you do 25 jumping jacks in place, or you run in place, you do a little bit of exercise for a minute. Then, what do we think would happen to the heart rate? We're going to make a prediction. Then, heart rate should, do you think it's going to increase or decrease? Okay. Do your experiment. Okay, and then record your actual results. So we've got, two different temperatures. We've got room temperature, we've got warm water, we've got the buckets to put your arm in, okay, for a cold environment. We have, you can do some exercise. Again, if any of you have an energy drink or a highly caffeinated drink that you haven't opened yet, but you were going to drink that could be a test as well. So if Red Bull affects your heart rate and you drink Red Bull, then your heart rate should what? Would it increase, decrease? Would there be no change? And then drink it, wait a minute, and see what your heart rate is. Okay. So you guys are going to do that, and you're going to record your results on this data table over here. Okay, so this data table, the key we're going to use, I have it written on the board here, and then N equals no change, I equals that the heart rate increased, and D, the heart rate decreased. Okay, so you're going to do your experiments, do 2 or 3, do at least 3 of these, okay, amongst your group, and then put the results up. Make sure that you have your argument here, your if and then of what you did with your experiment, including your prediction, and then we'll talk about this at the end. Now, words to the wise, okay? If you have some sort of medical condition, then please, okay, please let me know so that you don't do some of these things, because we don't want anybody to, to faint or anything like that. So there's 2 things that tests that we have here for you, and these 2 you must be sitting down to do this. Okay, so you must be sitting down, and one of those is the hyperventilation. So hyperventilating is you must be sitting down, and it's where you just take a deep breath very rapidly for about a minute. So you're going. Okay, for about a minute, and then see how that, if you feel like you're going to pass out or anything, that's why you need to be sitting down, stop, okay, stop, all right? And then we have the rebreathing, where you have a paper bag, so you'll get a paper bag from me, and you breathe in and out of the paper bag for a minute, okay? So that is the hyperventilation and the rebreathing. Again, you must be sitting down if you're going to do those two, okay? But if you have any medical condition, then please, existing medical condition, then please, don't choose something that might, cause you to pass out, all right? So you go ahead and you have them do that, and they put their results on the board, okay, in that data table. And then you discuss them, okay? So we discuss. All right, so what do we, exercise. So normal, okay, that's just at rest, no change, okay? So, and with exercise, pretty much everybody we should see eyes. For cold, usually I think we see a decrease. And then warmth, I think we see an increase, I can't remember. So you put all those things up there. I added caffeine and I added smoke. Because if anybody's a smoker and they want to go outside and smoke one of their cigarettes and then do their heart rate, then, put that up there. If anybody wants to do that. But it's not on the teaching notes. But if anybody is a smoker and they want to do it, then they can. Okay? They don't have to, identify themselves, but, they could go do that. All right, so we discussed the results, okay, after all the data's on the board, and this part takes about, 15, maybe 20 minutes tops for them to do their experiments, okay, and then, again, the water bath should be warm, not like hot, and so now we discuss the results, okay, and when we discuss the results, we want to discuss we want to now start addressing question 2. Okay, so we know now that variables do affect the heart rate, because we can see from our data table up here that we have I's and D's. So different things like exercise increased your heart rate. Okay, so now we want to look at the mechanisms that might exist to help us regulate our heart rate. And so there's a term we want to introduce called homeostasis. Okay? Now, homeostasis, okay? So homeo means the same, and stasis means like system. Okay? So the state of our system, which is our body, we want it to be the same. We want to maintain homeostasis no matter a balanced internal environment, no matter how the external environment is changing. So homeostasis is maintaining a balanced internal environment. So there are several factors that we regulate for to maintain homeostasis. So who can give me one? What are you constantly trying to regulate? Okay. Okay, our breath. So what do we want to put that in terms of? What, our O2? Okay. Our body temperature, right? Another one is our pH. Okay, we need to regulate our blood sugar. So these are just examples. Okay. So for example, your blood sugar gets low. That triggers your body that, hey, I'm hungry, I need to eat, so that you replenish your blood sugar. Okay? So this is the one that we're focusing on today. Like your temperature. If your body temperature, we have a set. So just for an example, here, our homeostasis is approximately what? 98 degrees Fahrenheit for our body temperature. So we're constantly maintaining 98 degrees. That's the set balance. Okay, the set point, what we want as normal for our body. No matter how hot it gets outside. Okay, when it gets hot outside, our body does stuff so that our body temperature stays around 98 degrees. If it gets too cold outside, then our body does stuff to maintain that homeostasis for temperature. So homeostasis is a term, okay? Now, how we maintain homeostasis is through what we call